My name is Darlin, and I'm the chair of 3 of the great groups within BCS, British Computer Society, which is the Chartered Institute for IT in the UK and a number of other countries too. Our charter covers us for a lot of professional activities, and we do not only have events for our members, but also we have a lot of activities for other people as well. For example, there's BCS publications, there's BCS training and consulting, and so on. But the focus of the groups that I'm part of is on events. The groups are London North, London Central, and London South. And in total, we can reach about 10,000 of BCS's members. BCS has over 60,000 members, and they're mostly in the UK, but also in certain other countries. And the knowledge of BCS is widespread, therefore, but also the knowledge within BCS. We operate in IT-related environments. So our events or other activities are to do with IT and the things that IT people need, which may be relaxation techniques, maybe other things like that. We don't go as far as food and drink, although we do provide some if you're here in person. The schedule tonight is I will give a brief intro, and then I'll hand over to our speakers. Talk about tonight's topic, which is about AI and the values of data. AI and data, 2 sides of the same coin? Maybe. We'll see. They will also take questions from the audience in-house and online, and we'll pick those up and pass them to the speakers. Following the talk and so on, we will then break for informal networking. Networking meaning food and drink, time to chat with people and continue the conversations. If, however, we get an interruption, like if we hear alarm bells, then I will advise you to go either that way. This is not if you're a term, of course, but if you're here, go that way and out the way you came into the building. Or else go this way into the big room, the atrium, and at the back of the atrium, there's a little green sign, which is its second exit going up. Please go there and proceed out into the street outside, where we may or may not give you more guidance. But hopefully we won't have any alarm bells or any interruptions tonight. If you have your own personal need to leave, then by all means do so. Try and do so without interrupting too many other people in the place where you're sitting. But if you need to go to the washrooms, they are that way and then again that way. So they're down there. Okay, that's about it for the housekeeping. But let me tell you now about this event. I've got the write-up, which you've probably seen because it's there on Eventbrite and so on. But here's how it goes. As AI matures from machine learning to GenAI and Agentic AI and beyond that, and these use cases evolve from experimentation into production, the symbiotic relationship between data and the AI model becomes increasingly clear. How to deliver real business impact. Smarter automation, better customer experiences, and reduction in costs. AI use cases are only as powerful as the data they're running on. So this is a slightly different angle to the ones we've had already in the season of AI-related events that we've held already We've talked about people, AI in different industries, different types of AI as it's evolved through just AI tools, the AI, agentic AI and Gen AI, the use of LLMs and all that sort of thing. In this session, Lyndon and Orit, who I'll tell you about in a minute, will talk about how to make data readily available for AI in business and how to model the business value of doing so. Now, as an aside, I ought to mention some very recent news that was published just before Christmas or just around Christmas, which is that the company that our two speakers belong to, which is called Confluent, has been involved in a partnership or a takeover, should we say, by a company you may have heard of called IBM. The Confluent shares, I think, were probably valued at somewhere around $20, $24.
One. 31.
No.
Oh, great.
No, before the takeover, they were probably valued at something like $20 to $24, I think. IBM has made the bid based on $31 per share. So if you own any Confluent shares, what are you doing here? Spend it. But it's been very good news for IBM and Confluent, I believe. And I'm looking forward to a great new future ahead. Why was IBM interested in Confluent? What does Confluent do exactly? What makes Confluent any more special than the thousands of other AI companies around? Well, these are things we will learn more about as we go through this session today. But let me tell you about the speakers. Lyndon Hedderly is the Senior Director of Value Consulting at Confluent. He's been with Confluent since 2017, and he leads Confluent's Value Consulting practice. What is that? Well, we'll find more about that as we go through. Confluent is a data streaming company founded by the creators of Apache Kafka, offering a platform for real-time data. Lyndon helps organizations model how Confluent and the data streaming platform can improve company performance, which includes explaining how real-time data and new AI use cases are two sides of the same coin. Before joining Confluent, Lyndon built a business value practice at Aqua, which was a digital experience platform company. And he was on the founding team of a UK startup with an enterprise infrastructure platform and analytics solution. Before that, Lyndon spent 12 years with Accenture's IT strategy practice. So a lot of years in data and digital strategy. Orit, do I pronounce that right? Is the principal and head of strategic customer advisory of EMEA at Confluent. There, she partners with the company's most strategic enterprise clients across the region to align their data and AI strategies with measurable business outcomes. And if you'd been here a few minutes ago, you would have heard Orit and Lyndon talking with a senior manager at IBM about some of the directions ahead, I guess. But possibly more of that later as well. Orit began her career as a software engineer in quantitative trading before moving into strategy and commercial leadership roles, bridging technology and business impact. Over the past 15 years, she's been in Palantir Technologies, Evolution AI, and Strategy and helping organizations to harness data to drive growth, efficiency, and innovation. She's got an MBA from Columbia Business School, and a BSc in Computer Science and Communications from Tel Aviv University. So we have a truly illustrious background there, and that's matched by Lyndon having a master's in neuroscience, including neural networks and AI, from a place called Oxford University. Is that
Heard of it.
US? So those are our speakers. I think we're in for a pretty exciting event and lots of revelations in terms of the worlds of data, AI, and the future. Please join me in welcoming Orit and Lyndon.
Well, thank you, Dalium. That was a fantastic introduction. So a lot to live up to. And really pleased to be here. Thanks for everyone for coming. Hopefully you can hear me okay online. We don't need speakers. So yeah, we've done the introduction. So let me talk a little bit about Confluent first, and then the structure of this talk. It's in 3 parts. So Confluent was founded in 2014. I joined in 2017. And around 2011, there was a team at LinkedIn based in California, San Francisco, and the team at LinkedIn were really struggling with the new features and functions they were offering on that platform. So there were things like friends requests and job recommendations, and the data, keeping the data in sync as they were expanding both globally and in feature and function was really challenging. And they were toying with different database technology, and the database tech just couldn't keep up with the scale and the real-time requirements to offer a unique interface to every single person of LinkedIn. They tried different technologies to keep data in sync. They tried messaging and ETL type technologies to move data around, and nothing was working. And the engineering team basically said, okay, well, can create something, and they created a technology that worked off a log rather than a database, which is actually how a lot of database works. They work by this kind of change data capture log that goes into a data in tables, and they ended up calling that technology Kafka. They open sourced it to the Apache Software Foundation. It became Apache Kafka, and it was so successful. It was adopted by so many digital native tech first companies that they said, hey, let's leave and set up a company. So they left LinkedIn. They were part funded by LinkedIn and set up Confluent. And Confluent kind of started offering support for Kafka for the first couple of years. They started really selling in 2016. I joined in 2017. So I was employee number 100 or so globally. And we set up from there. The company went public in 21, and yeah, IBM, I was talking to Mark earlier, so IBM has put in an offer to buyers, and that deal should transact sometime in Q1, we expect. So that's a bit about Confluent. By the way, feel free to stop, ask questions. I'm happy to keep this very informal. So get on with the talk. It's going to be 3 parts. I'm going to talk a little bit about that history and how Confluent, where we see Kafka going. And then the second part, really how that applies to AI. And the third, we talk to a lot of organizations and people who struggle with then communicating that kind of data and AI and value into the business. So we're going to talk about how we address that in our business. So that's what Orit and I do day in, day out. So yeah, I'll get going. Any questions before I start? So can I ask a question? Who has heard of Kafka? Okay, that's good. And who works directly in data? Yeah. Okay, so it turns out that getting value from your data is much harder than it should be. And why is that? And if you go and talk to business people, they often get frustrated because they see IT as the owner of data, and they say, hey, I want to build a new feature and function in this app, and IT come back and say, fine, that's going to take 2 years and £2 million. And there's this constant kind of challenge. We should be able to access data more easily than we can. And here's one of the challenges. So typically the way we've built data or worked with data is to build it and put it in a database. And it's just how we've worked for kind of forever. So we take different data sources and pop it in a database, and the database is organized by tables, and we do kind of query response, request response type analysis on tables. And it's worked. Right? Largely worked for individual applications. But then as you grow, often applications in what we call an operational estate want to pull data from different sources. And we end up with an architecture that starts to look a bit like the spaghetti kind of diagram. You've got an application over here. Let's take a retailer. So a retailer seems pretty simple, right? You go to a point of sale in Sainsbury's, you buy something, you think that's a single transaction. It turns out there's many applications happening. So that there's a financial transaction, there may be a payment to your credit card, maybe there's an update to your loyalty card system, maybe there's a ping to the supply chain inventory management solution, maybe there's an update to the pricing application that manages dynamic pricing. And you might have 20 or 30 different applications off that single transaction. And that's how we've evolved in the digital world. And then on top of that, from that operational estate, you have an analytics team who want to look at the data. And the way that they've evolved over time is to say, I'll just take as much data as I can, I'll put it in my database, my big data mart, data warehouse or lakehouse, and I'll run all my analytics off that. So these people need all the data from here. So we have this one-way flow, operational estate to an analytical estate. That's just how enterprises have evolved. And it's worse than that because it kind of gets like really messy really quickly. There's multiple databases, multiple warehouses, multiple operational systems. These are often real time, by the way. So you expect to kind of a push and response, especially in applications and online. This team often accepts that there's going to be a delay, that this processing data from here to here is going to be in batch with ETL, so extract, transform, load to data. And so sometimes that happens daily. Remember that when we used to go and spend things on a bank statement would appear maybe even kind of a weekly update on a bank statement. Now we expect that to be instantaneous. And in the operational estate, we might even expect alerts on our banking app. The data has to go from here and then back here maybe. And you end up with this giant mess, right? It's kind of, it's complicated. And then the business say, hey, I want a new application, new feature. And IT says, oh, well, the data's all over the place. It's going to take 2 years and £2 million to build that. So that's where kind of how data's evolved. And we have mainframes and IBM that are just really solid and robust and can scale. We have to suck data out of those to get them into that analytical estate. And we have new technologies bolted on all the time. So that's where we are. And we have to build these applications of that. So as we digitize, we want more and more applications, and the expectations of those applications has gone up. So this is where the LinkedIn team were in 2011, 2014. They were building new features and functions, and a single app. Let's take Uber as an example. We tend to think of Uber as a single application. Actually, that's another good example of it's many different applications, right? There's a GPS app, there's a finance app, there's a source, a driver finding, sourcing app, and multiple things that all need integrating to offer ultimately integrate data, track location, track which driver's available. Maybe that driver's actually on the job, but maybe as a drop-off point, there's going to be more. So there's complex algorithms processing of this in the stream of data, and a lot of the digital world now looks like this, and it's built on this massive mess. So that's like just a bit of setup. I would say a read.
on behalf of the audience, thank you, Lyndon, for the history lesson. Sounds like you've been around for a while, so thanks for that. But I think at this point, everybody here at home start to ask themselves, very interesting, but what does all of this has to do with AI? So we're going to try and answer that question. So Lyndon has walked us through the complexity of our legacy estate. We understand why it's so complex, and I think everybody who's been in IT for a while understand that. But now this question is not just our business. This is a question that is kind of the most urgent one in the room, and that room is quite often now the boardroom. And the reason for that is AI. So I have some numbers here. So some of you may have seen those already. Generative AI, I'm not even talking machine learning. GenAI is estimated to add up to 4 trillion annually in dollars to the global economy. And obviously everybody, enterprises, governments, everybody's clamoring to get a piece of that. And they're investing billions and billions into different AI initiatives. This is all, by the way, quite small footnotes, but McKinsey, BCG, Gartner, so only the source data. They're all investing money into it, but we have again solid data that says that up to 3/4, according to BCG, of those initiatives fail at the proof of concept stage. There was an MIT research that recently, I don't know if has anybody heard of it, that says 95% of GenAI initiatives fail at the POC. So why is that? Obviously, everybody's using the same models, right? ChatGPT, Claude, Gemini. Why do some succeed, not many, and why do most fail? And what we see, Lyndon and I, day in, day out, the differentiator here is the data, the enterprise data. It's the bottleneck, and this is also quite often the obstacle. So what do we need to do to get AI working and to start seeing ROI from AI? And I think first I'm going to take a step back and talk a little bit about what's one of the key differences between traditional software and GenAI where we are today. So traditional software, everybody who ever coded, is very deterministic. You basically build a decision tree. Every action has an outcome. You build it, you debug it, you release it into the wild, you find the edge cases, you tackle these edge cases. At the end of the day, you have something that works 100% of the time, more or less. With GenAI, like anybody who ever tried to ask ChatGPT or Gemini to generate a photo, you actually have quite limited influence on the final outcome. It's a probabilistic model, it's not deterministic. So if you get to a level that you release your AI agent or whatever it is, again, into the wild, and you're happy with the outcome, 95%, you're probably doing good. But obviously for an enterprise, this is critical. I mean, if an Agentic AI improves a mortgage application for a bank, if it finds a bad player, in like fraud or money laundering, or if it fails, has quite critical outcomes. So what do we need to help AI, kind of deliver better outcomes? And we think there are 3 key things. The first thing it needs to do is learn from the past. So you need to have your historical data in order. You need to have a single source of truth, and the data has to be trusted, consistent historical data. Second thing, adapt in the present. So this is all about context. GenAI is all about current context. The data has to be real time, and it has to be based on real time signals. And finally, you want it to be safe at scale, obviously, right? And be kind of not entirely black box, to be able to understand why it takes certain actions and influence these actions, and with low latency. Any questions so far, by the way? I haven't kind of stopped for a breath.
Yes. Sorry.
Most organizations do not have a single source of the truth. They do not have trusted data. And to get to that point can be quite difficult.
So what do you mean when you say they don't have? I mean, a client has, like your bank account has the balance, right? Or the airplane has certain numbers that are free. So what do you mean when you say it doesn't have?
Saying that, most of us have worked in organizations where the data is not A, a single source, and B, necessarily 100% trusted. That's what I'm...
Yeah. And this is why if you feed the model bad data or data that's out of date, you will get funky results, to say the least.
Yeah, I can comment on that though. Can I just say, was there another question? Then I'll come back
It was very closely aligned with the previous one. I got a certain feeling of deja vu when I saw that slide. It seemed like, yeah, we put AI on it, but they're the same problems we've been dealing with for the last couple of decades or more.
Yeah. So shall I take the clicker and then we
Can I just like quick answer and then I'll hand
Yeah.
off to Lyndon. And I think the difference is, so now it becomes kind of more urgent and more high level, because before that, you had a person looking at the result of an anti-money laundering investigation. They kind of had more space to say, well, this is wrong and I'm going to spend more time on it. Once you kind of hand over that responsibility to an agent, you know, you kind of want to make sure that you have your ducks in a row as much as possible. So I think that's just my perspective on it, if that makes sense.
Yeah.
But you wouldn't hand it to an agent though, unless the business was secure in the knowledge that the agent was going to do a better job than the human in that case, would you?
Yeah.
So so I'll address all points, and I think that I 100% agree around organizations often lack single source of truth, and I think that spaghetti giant mess picture that I showed earlier is a symptom of that. The database technology, the way we've evolved and the way applications tend to want to work is to take their own kind of copy of data. So most of us know when we work with data, I mean, we all do it, even with Excel, we often just take a copy and then we've got our own little kind of set of data. And then when that happens multiple times across organizations, how do you keep them in sync? So then you also have a trust challenge. And a governance challenge, and then you have kind of quality and overlays, and that then AI on that then compounds the problem. So at the risk, and by the way, I don't want this to sound like a sales pitch, so just at the risk of sounding a little bit like a sales pitch, but it's coming from an honest place. So the purpose of data streaming, or one of the benefits of data streaming, is what we call shift left. So with any data source, you have an event that triggers the data, and then you have a series of things that happen to an action. And that action may be that the data goes and sits in the database for analytics purposes. The action may be that it's just like something happens and something else happens. And you can automate that, and it's machine and driven and so on. But by shifting left, you're shifting closer to the event. And a benefit, like let's say an event can be anything really that happens in a business. So it can be a payment, a trade in a bank, it can be a customer experience, someone logs in, or it can be anything that happens in a business. And with the database, what we tended to do was take that event and put it in a table. And then, as we saw with the spaghetti, we'd integrate and make a copy, and then and that's where you get a problem. But with stream processing, which is a Kafka based, so open source, so not the sales pitch, because this is free, openly available technology. But with Kafka, the idea is you take events and put them in a log, and that log can be stream. So a good way of thinking about this might be a database being analogous to a bucket of water, and streaming data being analogous to a hosepipe data. That's a good kind of one way of thinking about stream data, and that's ultimately what Kafka is. Stream processing. So you take events, you can shift left closer to the source of the events, so your data is more true, so you can trust it more. You don't, in theory, need to take copies now, because these events can be subscribed to. So anyone wanting to understand what's happening can subscribe to events. So that can be your customer application, it can be your banking, trading, reporting app, it can be the analytics or back-end operations. They can subscribe to data. And in theory, you only need then the single source, which then can be trusted. You can actually govern this with rules in the stream. So ensure that the data is as you'd expect, and maybe knock it out if it's not as you'd expect. So we think of stream processing in a very different way to database technology. And that was to ultimately, as I mentioned, like originally, to address challenges of scaling at LinkedIn. we now see in every industry, every organization working with that large scale data where real time is a requirement, but also where scale is a requirement, because Kafka can work both in real time as one of its high kind of benefits, also that it can work at high scale with complete redundancy is other kind of key benefits, which is why the digital natives adopted it, which is why now we see it in banking for payments, for trading, for risk analysis. We see it in retail for inventory management, for, again, payments. We see it in telcos for network inference, we kind of see it in every technology that uses data.
I just wanted to ask, by focusing on the events, are you saying essentially that you can enhance the metadata associated with everything because you're capturing metadata at every single event across the data lifecycle? So you're improving the provenance and other metadata that might be lost otherwise.
Yeah, and that's exactly right. And with streaming, you have a concept of retention. So you can, and sometimes the stream can have data where the retention is set to 1 second. So you might act on it within a second, and if once you've used it within that second, it's gone. It's gone forever. You can set retention to be infinite. So you're maintaining data as you would in the database table. The difference with table, you would overwrite data essentially and then lose it through overwrites, whereas a stream, you never overwrite.
Thank you. I've actually come across your company through just searching about various things on YouTube and finding very.
Could you speak up?
Sure. Sorry, I've come across your company through YouTube videos, which are very, very informative. What I'm still having trouble with is understanding the difference at a high level between Kafka and traditional message-oriented middleware. I remember a few years ago, we were obsessed with message buses. Bus this and message bus that. So if I came to you and said, like, I've heard of message buses, they seem to do pretty much the kind of thing you were explaining. How would you sell Kafka to me? You know, what is so different about Kafka compared to, say, I don't know, RabbitMQ or something?
Yeah,
but that would suggest that I should go this way rather than go towards RabbitMQ.
So let me kind of 30 seconds with a quick answer. It gets very technical very quickly, and I might be a bit boring, but I'm more than happy to answer it later. But in short, there are different ways that we've grown up to move data around. And we have ultimately, before Kafka was created, we settled on 2 ways. Like one was ETL, extract, transform, load, is like batch process, taking data, processing, and putting it somewhere else. We do that many times often. The downside of that is it's batch, so you schedule it once a day, once a week, sometimes once a month or longer. That's one way. And the other way was messaging tech. And at LinkedIn, the team was kind of struggling with messaging tech, and the challenges they had were scale messaging. It just didn't scale. So you had to add lots and lots of servers. If the server went down, you lost data. It became super challenging on like so many levels. There are other very technical reasons why Kafka is kind of so much better in terms of its resilience, high redundancy, failover, and speed. And fundamentally due to the kind of log architecture, and I can explain more. But is that good enough for now?
No, that's great.
Okay, so that's processing. It's different to database technology. There are overlaps. Sometimes a database is a better way of storing data. Typically, if you're working in an operational estate, this streaming data is a much better solution. We can also bridge that kind of group to the analytics. And often in analytics technology, we have this kind of, we're seeing more and more with AI and machine learning, this requirement to use both operational and the analytical and analytics estate to get to an answer. And this provides a really good architecture for that. And then and AI came along, and I'm going to hand back to Orit, I think, but what's interesting to me is that like Kafka was created way before AI, so more by accident than design. It turns out streaming is a fantastic architecture to underpin AI, and that's so we're in a great place, and I think partly Darlin mentioned IBM swooped in, and there's just before Confluent, the transaction should complete this quarter, 11 billion, and IBM see Confluent as being absolutely core to their technology and stack for AI and managing data going forward. And again, I think it's like a really interesting time. So you were going to go.
Just to recap a little bit what we spoke about, we started with a history lesson explaining why is it such a complex problem. And sorry, to your question, right? So certainly the big enterprises who has been building IT systems for 30, 40, maybe 50 years at this point, they have this problem the worst because they've been building operational systems that were meant for operations. No one thought about data, no one thought about AI, and now we arrived to this problem. So we started with understanding this complexity, and then we spoke a little bit about why that makes AI, GenAI specifically, such a difficult problem to solve, and why data streaming actually it's kind of, we think obviously that is the right solution, and IBM seems to agree to the tune of 11 billion. But now I think we're going to try and bring this conversation and which most AI conversations are kind of at the very 10,000 feet level, and we're talking about the trillions of dollars and about all this amazing potential. But at the end of the day, most of us live in the world of IT budgets and IT programs. And how do we, and I think this is something that Lyndon and I really do day in, day out, how do we convince the decision makers, the budget holders, how do we actually convince them that potentially investing in data, which is not necessarily the sexiest of everything, that this is actually key to delivering on AI? So I'm going to hand it back to Lyndon and going to talk a little bit about what our team does, our process, and hopefully you will find it informative.
Yeah, thanks. Yeah, so before I start, like who in the room has to put kind of cases for investment in tech or new applications or so quite a few. So we often get asked to help support that process, and this is how we do it. And it's kind of interesting because you've got really fun stuff around AI, new AI use cases, and it's always fascinating to kind of read that. But then ultimately, a lot of it comes down to this underpinning data infrastructure, which, I mean, at the end of the day is quite a dry subject potentially to talk about moving data around. And we have to kind of bridge that gap between really interesting AI, how to put that forward, and a bit like the data infrastructure. So we just do that with this business case framework, and I'll talk this through with an example of an AI use case we've seen in real world with one of our customers in the airline industry. So they wanted to invest in improving the customer experience. So the end customer, when their flights are delayed or they're delayed and the flight's on time, or there's issues at the airport, and they want a better app experience where the app can respond to natural language questions and almost like a human type interface of but so what we can do is we can say, okay, what does it look like today? So what's your current as it state and the negative consequences of that? What's the baseline? So the baseline is people hate the app, they have a really terrible experience, they kind of miss their flight sometimes, and they get misdirected when the flight gate changes and the updates aren't done in real time and so on. And so you can quantify, you can log those negative experiences in both a kind of qualitative way of people have a bad experience. You can potentially put a quantitative number to that in terms of like customer drop-offs. You can estimate that some people are booking with another airline because they don't like their experience. But you agree on the parameters, the assumptions, the estimates that go into that baseline. And then you look at, okay, well, so what's the desired state? What's the target state? In this case, it was have an AI-enabled app that is looking at that stream of data. So remember the previous slide, the stream, like in this case, all the different streams are weather, gate information, arrival information, passenger static data from the customer 360, the flight information. That's all in the stream. So it's a steady stream of data. It's constantly changing. So that then goes into a platform that can process and govern data, and with an AI add-on can respond to natural language and offer alerts and other things. So so now the person is in traffic, their flight's on time, they're going to run 2 hours late. The check-in's 2 hours, they may make the flight. They can have the query, I'm in traffic, I might make my flight, I might not, what are my options? And through the processing, this, okay, like you can risk it, but if they're not, there's another flight in 2 hours. Do you want me to book you onto that flight? Yes or no? I'll tell you what, I'll risk it. But what if I don't make it? Can I book on the flight? Yeah, you can have all those conversations, and this offers an amazing experience. It's cheap, relatively kind of cheap to support. So you put that in the design solution, and then you identify what the benefits of that would be. So there's a cost to implement it, obviously, which you need to offset, but the top line benefits, vastly improved customer experience, better flight management. If there's delays, if there's an issue at the airport that we saw at Heathrow a few months ago, which by the way cost kind of many hundreds of millions in terms of displaced flights, you can manage all that in a much better way. Then you look at does the business case stack up, and you can look at scenarios. What if the project overruns and costs twice as much as we're estimating? Do we still make a return on investment? And then you look at maybe where you've done it before. So this is a process we go through with customers. We kind of take that 5-step and work out ultimately whether there's a return on investment, and from both a quantitative ROI, but also a qualitative.
Quick question. In your target state, the design solution, was that a package that was provided by a vendor, a licensed software, or was that something you had to develop?
So actually, most of the time it's a combination of packages of software and services, software as a service type. So in Confluent, for example, there's a platform for data streaming as a service that we host on cloud service providers. So that's some kind of consumption-based subscription. But then you would probably have a GSI or partner to develop the AI component of that. You may have other components within the overall solution. Ultimately, you probably have some sort of data warehouse type add-on at the end, whether that's a MongoDB or Databricks or Snowflake or some sort of warehouse under which we would integrate to, and then there would be application functionality on top of that.
Yeah, I was just thinking about the application functionality element of it, to AI sort of chatbot type.
Yeah, but that's not our bag in the way that we are very much that underpinning data infrastructure layer.
But kind of to your question, and I think as per what we were talking, so you can have the most sophisticated chatbot. At the end of the day, if that chatbot doesn't have access to the latest data on which flights are on, which flights are off, how many seats are filled, if it can't access, and know like what's the single source of data about this customer, how many miles does he have, or in this case, then there's a whole thing is not going to work. So in this case, yes, so we're looking at the business case as a whole, but we will argue on whatever you're working on. In this case, Confluent can, credibly claim, and here is again, the impact will be hundreds of millions, potentially, if not more. We can say Confluent, we confidently say that Confluent owns 5 to 10%. So as general, when you do something like that, always err on the side of being conservative. And everything has to kind of be very common sense. But why wouldn't that work without Confluent? Because, well, you're not going to have the up-to-date data, you're going to have multiple, you're not going to have the governance, you have some risk, etc.
It's a typical business problem, isn't it? When the business guys see some kind of demo of software, like you mentioned, it was an AI play. Well, it's a business play, really, isn't it? And they saw that. But then the iceberg is the data and the infrastructure underneath it, isn't it?
Yeah, exactly. And I don't know whether if anyone was paying attention, I think Orit mentioned that, what is it, like 95% of AI pilots don't get into production. And actually, the way a lot of organizations have set up AI pilots is they've taken the model and then they've taken a data set, which is a static data set, a database probably in tables, or fed it, and they're waiting for a result. And they kind of test that result against kind of expected result and see the model. But when that then gets into live production, that static stream, as Orit mentioned, that static data, sorry, becomes a live stream. So it's constantly changing things. And, you know, flights get delayed and issues happen at airports and gates get changed. And that needs to be absolutely up to date constantly to offer those three things. So the AI model needs to do, and Orit's slide earlier, is kind of respond to what's happened in the past. So the person understand their status, manage what's happening right now in the here and now, so the stream of data, and then respond to it without lag. It's like absolute real time serve the responses. And in this case, it's a customer. It's a customer with an app figuring out whether they're going to book the next flight or this one. In a lot of cases now, that's actually another machine. So it's machine talking to machine, and you're removing the human, the process completely. But so this is one kind of approach, and we try and make that real and get to quantified and qualitative business value. Really, there's a lot, and it just comes down to numbers from a pure business perspective. But then what we find, and Confluent at the end of the day and Kafka, it's a very deeply technical solutions. And you know, this when asked about messaging, and can talk about point to point versus pub sub type models later, but it's deeply technical, and often the sticking points come in the tech, and you're trying to talk to a business person about why they can't get their AI here and now. And so we've developed a kind of bit of a model internally to help with that explanation, and we thought it might be interesting to share here and get feedback. I don't know. So typically any organization is hierarchical. You get this kind of C-suite, and you get lots of different business units, departments, teams, and this obviously a big complex enterprise, global enterprise like Shell is a lot more complex than a lot of smaller digital natives, but broadly they follow this structure. And what we've found through constantly kind of talking to people about data infrastructure, data streaming, also AI and the business, it's useful to kind of break this conversation into 5 layers. So when we're talking to practitioners working with data, like hands-on with Kafka, or DBAs or developers and operators, it's often like you can really dig into the product. You can talk about the features and functions of the platform. But if you are talking to their management layer, they just want that to work. They don't, not too asked about the detailed features and functions. What they want to know is it going to operate efficiently? Can they run it with fewer people than if they were using a different technology, or can they run it with less infrastructure, or can they run it on the cloud as a managed service? Or that's what they care about. And then you've got a team of people who really care deeply about the data, and the data being trustworthy and governed, and it is GDPR compliant and so on. And that is important to shift left to and think about data products and managing data. And these people don't care often about detailed tech and product and throughput and latency. And equally, these people often don't really care about the data. Like they just know like the technical aspects. They can tell you that it's X gigabits per second. So, but then you've got like business applications teams who really want solutions and use cases. And again, often this doesn't like translate. It's almost like you're talking different languages across layers. And ultimately, this all has to stack up to align to the business vision and mission, and our language that the C-suite would totally understand, where they might ask, the first question might be, how's it going to improve my revenue, or how am I going to save costs? How am I going to manage risk? And that is a very much a pattern that we're starting to see in as we talk about AI. And it's just an interesting reflection. I've seen a few people nodding and kind of seem to recognize this. And so that's, yeah, we just want to share that. And then often when we're talking to customers, we've always got a team in procurement who are beating us up on price as well. But those two frameworks, that kind of business case approach where you're telling a story with current state, target state, the benefits, if the ROI stacks up, and then where you've done it before. And then these 5 layers tend to kind of work quite well when we're pitching, or kind of when we're talking about AI. This is a picture, it's not mine. I stole it off. It's like a common meme. I'm sure everyone recognizes that arts type meme. But when I saw this picture on the internet, and I kind of thought of what we do is often down here, like this data streaming. And again, I mentioned it's more accident than design. I think data streaming is a perfect way of managing data for AI, much more so than databases. That's really fundamental. But we're still kind of this house holding up all this AI infrastructure. And AI is just kind of really exacerbating this kind of challenge of this stack of it resting on the solid where we've shifted left and right. So I just thought that was funny as a closing point. And I guess to kind of summarize, so we talked about the history of data, talked about then why AI needs not just static data, but it needs to respond to real-time data in the stream to then serve up data, and the streaming data kind of architecture is a really good fit for that. And then we talked about how we take that and talk to businesses around how to articulate the value of data infrastructure and AI. So hopefully that was useful. Thanks for listening on a Tuesday night, but yeah.
I was interested to ask, so obviously you focus very much on real-time data and on essentially one data quality dimension, timeliness. But of course, there are many other data quality dimensions you might want to consider. And as we all know, data quality is contextual. So I would speculate that one of the reasons why many AI initiatives fail is because there's not enough metadata available to express the data quality expectations that would be required to support any particular use case. So that's why my earlier question about metadata generation was sort of framed that way. So I think while I sort of respect points you've made, the far more fundamental point is around data governance and the availability of metadata. And I would suggest that most organizations fail the test of managing their metadata effectively. And that's the Achilles heel that organizations will suffer from in trying to deploy AI.
We did touch on that when we talk about kind of, safely being able to scale. And yeah, not to pitch, but we actually, it's a problem that we recognize, and it's part of our shift left strategy, which Lyndon spoke about. And actually we have a governance product, which basically enables to add that some sort of metadata, or like in, as close as possible to the source of the data. And there's just, it just stays there basically, and no one can really touch it afterwards. So quite often the problem we see is the data comes in, and then somebody else, let's say from the data team, so you have kind of the DevOps guys, or the guys who kind of take that data, right, like from the source. And then much further down the line, or to the right, somewhere in the analytics stage, you have the data scientists, and they see this data, and for them it looks brand new, and they don't know much about it. And we have had some of our clients had disasters around that, where people kind of, data that was not compliant, or, real.
But I think the message for me is that this isn't fundamentally a tooling or technology problem. This is a cultural problem around the way organizations value their data and treat their data as an asset. And until we can get over that hurdle, then many of this technology aspects are going to be sort of secondary.
Yeah, I think in my mind, I'm kind of hearing your question in two parts almost. So one is like around metadata, and then another around context. And then I know you draw context from metadata.
And culture.
But I think for AI, and specifically AI, like context is a huge challenge, actually, because AI, will hallucinate, but more context you drive into it, the better it gets. But I think specifically the metadata from a deterministic perspective, when we're talking about traditional software, we can kind of we can address that mostly. We can capture events and we can attach metadata and timings and governance and who can access and role-based access controls to the data. We can do all that from but context is.
But I mean, what you're describing is what you can technically do. What I'm talking about is what organizations actually do.
I totally agree. And I think if anyone in this room knows where AI is going to be in 3 or 5 years' time, I mean, none of us really know, do we, in terms of how good it's going to be or not. It's a really, but that's one of the major challenges, I think.
Don't know the answer to that question, but I think you're right. I think the cultural issue is a big one, and you know, I'm in data management. I've been, that kind of area, so I'm kind of used to hearing these arguments. I mean, first of all, it's difficult to put a value on data, and organisations struggle to. So you know, you got the same argument with AI or that kind of new technology, and the only way I see it kind of where you can start to make headway in that is to break it down use case by use case, isn't it? So the example you gave there, you know, if you're able to value what the potential benefits of the solution, then you simply concentrate on, it's not simply in many cases, but concentrate on that data that is part of that solution. So you're not trying to look at all the data. I mean, organizations will put their enterprise data into the context data that doesn't change a lot. You know, you can put that into some kind of gold database, but some of the operational stuff changes too much. Sometimes they want to use unstructured data that's not even part of their own organization. You know, that's the way things are these days. And the only way to start addressing that is to break it down use case by use case and everybody in the enterprise these days touches data. Everybody in the enterprise is affected by data. That's where the culture comes in. You most of the time, somebody will have not entered that data the way it should have been, according to the system, and that's what causes the problem later on. It's a big challenge. But it's interesting. AI is another layer on top of all that, isn't it?
It compounds the challenge. I think there's a question at the back.
So I remember the days of MQ a few years ago, and one of the challenges we had was that a single use case was very hard to deliver business value. But if you had a multiple set of use cases, then that would drive significant business value. My question is, I think that's what's happening is quite a few of the AI POCs, because they are single use cases. Do you see that? Is that something you know about or have visibility of?
So I think that's a really good point. And we see that a lot, and actually a slightly different way of looking at that from a software vendor perspective. So we can sell into a single use case, but we see the value that an enterprise gets. They're running a platform where every bit of data is feeding in, and anyone can, with the role-based access control, can access the data. That's where the real value comes. And it's what it's worth. We tend to see enterprises go on a bit of a journey with us. So large enterprises might initially buy our streaming platform for one specific thing. Let's say a bank for payments, and it's locked down to only payments. And then the same bank might have a department over there that uses it for its risk analysis. And then the same department might use it for, I don't know, regulatory reporting. They want to stream all the trades that happen, various, I don't know, MiFID compliance or and then we see that kind of similar pattern happen in 10 or 20 different parts of a bank. A big national kind of global bank, and it had 50 different contracts with Liverpool. It's kind of insane how many different teams. And then there comes a point where they're like, hang on, this team actually would find that information useful, and this team would actually find, so let's start to share the platform. There's lots of consolidation benefits of that in terms of infrastructure management, but also with the right access and separation. That's the massive value. The value just goes exponential. Does that answer the question?
So I think the question was about this 95%. You have to be very careful with figures like that. That 95% comment from McKinsey, if you dig into it, there are a lot of different factors, not just data, that cause that 95%.
It's a very good point, and I think ideally you work with, you need to pick the right use case, basically. So you need to pick the right use case, the right set of use cases that you can actually show that sort of ROI clearly, and this is definitely part of the challenge.
But it becomes part of the infrastructure, doesn't it, eventually? Yeah.
I mean, yeah, for sure. There's so much more. I mean, we're like, in all kind of transparency, honesty, we work for Confluent, probably can talk with some authority about data infrastructure and platforms around, like, I don't know, culture of managing data. It's like, we're probably not the guys, so maybe next week we'll get someone else. There's a question.
I read about by 2030, AI generated synthetic data will totally overshadow the human input raw data. So from your technological viewpoint, when you do the data streaming, do you treat raw data and AI generated synthetic data differently or equally?
Depends on, I mean, we look at the source of data. We're in a sense, we're just a pipe. Like basic Kafka, it really is a pipe. So it's up to the user to decide what goes into the pipe, and what to do with it. I will say, for example, I'm not sure if it's relevant, but and this goes back to kind of the data processing, which is, I think, is not Kafka, but is also part of our platform. And it actually allows you to make this kind of decisions on what data you put into the pipe, if you will. So, for example, sensors, right? So telemetry, so volumes of data. Like, say you have, you want to keep the temperature in the building as per. It was a bit cold in the atrium before, right? So you want to keep the temperature in the building, comfortable, or you want to drive some data out of that. And typical systems, they would just send the sensor data, right? But if you think about it, if the sensor, how many sensors do you have every second? 25 degrees, 25 degrees, 25 degrees. I left one. But actually, this is not important, right? You only want to know when the temperature changes. So, for example, we have Flink, and Flink, this kind of data processing, it's very basic decision is just say, well, as long as the temperature doesn't change, I'm not sending anything. And only once it changes, I'm going to kind of send. So again, I'm not sure if it's entirely relevant, but you can decide on some sort of mechanisms to decide what data is relevant. It gets expensive if you just put everything in.
So the reason why I'm asking is, as you know, AI has hallucinations.
Yeah.
So you cannot really treat the AI generated synthetic data same as the human input raw data. Like temperature is raw data because it just happened. So I kind of established that your technology is just a pipe. You don't really make decision or filter out that is wrong, that is right, that is factual, and that is hallucination, right?
To attack it.
I think
Yeah.
what we say is kind of, by using data streaming versus static architecture, you lower the odds of your AI hallucinating because the contextual data is as up to date, because as much as possible, it's a single source of truth. But again, it's a probabilistic model. It's not deterministic. You never do know what's going to come out the other side. So, people now talk more about, we're augmenting people. We're not looking to replace. It depends on the use case.
Yeah. Thank you.
I just wanted to point out that people online might be asking questions. So
Yeah.
working on this more.
Are there questions online that we should take?
There's no question at the moment.
Okay. Yeah, I mean, I just have one kind of on that final question. There's a definite trend where humans have been removed from the process, and we saw that pre-AI with digital, and we're now seeing it accelerate with AI. And it's fascinating that, and again, this goes way beyond our talk today, but there's mentions that AI will create its own language, right, and then start communicating with itself, and kind of to a point where we now no longer understand what AI is doing, and AI is going to take over the world. And
Good to know.
yeah, so and that's all I mean, it's fascinating. I think we're all kind of watching, and who knows what's going to happen. But
I think those are the aspects that are particularly different to or data management or whatever we've been doing with data in the past. The fact that there's like a transparency in the processing. The fact that you need to know what the data has been trained on, in order to be able to assess the outcomes, and that's kind of the new, in my opinion, anyway. A lot of the other stuff is like same old, but with a shiny plate bolted on.
And I know I'll come on to, and then kind of one final point on that, which I was reading about kind of over Christmas, and I'm not an expert on this at all, but kind of the current AI has grown up from it's moved software from the deterministic to a probabilistic model. There is a kind of school of thought right now that probabilistic model isn't the right model for AI, that actually a better model for AI that becomes sentient is like a contextual GenAI that now no longer probabilistic. So it has actually some form of understanding. So if AI was ever going to become sentient, which I don't believe it will, but
I give it a couple of years.
it's probably not the current model that's being built on probabilistic. Probably the other, another way that hasn't quite come out yet. But sorry, there was a question.
Yeah, when there's a pattern that we use when we are taking monolithic architectures and trying to build them into service-oriented architectures, which seems analogous, if not connected here. So that's the strangler-fig pattern. Where you start routing things differently in your organization. So is there a pattern that you typically find yourself using when you're coming in and starting implementing streaming?
So
organization.
So in terms of a service-oriented architecture, like SOA, we definitely see streaming as being a vehicle to get to SOA in terms of breaking up a model. So in other words, let's say you have a big mainframe, and you're a bank, and all your financial data is held on the main. And someone says, "Hey, I want to offer a better superior customer experience, real-time updates on alerts if someone's overspending on a limit." So turns out, if you develop that in the mainframe, it's take years, and people are really not going to be happy. Mainframe's already creaking a bit on a bit of that, but so forth. Second. So the mainframe people don't want you to touch the mainframe because it's sacred, and then they say, but you can suck out the data, you can build it in your own digital app over here and offer that functionality. So the pattern we tend to see is, rather than instead of, but it's like an in parallel addition to existing architectures where data goes into the mainframe's sacred and remains, but it also gets fed into through a data streaming platform that streaming. You build the application separately. I mean, there are potentially challenges to that as well in that. So, now you've broken the single source of truth thing. And over time, though, what you might find is do that enough times and ultimately start to deprecate components of the mainframe with a view to ultimately turn the mainframe off. And now you've got a digital architecture. So there are patterns that we do see kind of breaking up the monolith. Service or SOA, like this is like publish an event and then subscribe to events, and then you can retain or not. And it's very simple actually, and so you can implement that for many different components of like data, and it turns out it's a really good pattern to break up, modernize. Does that answer the question?
Yeah, well, it helps. Sure.
Mark.
Thanks. Yeah, interesting stuff. Yeah, I'm still trying to get my head around, probably some people, the real-time aspect, because I thought it is event streaming. So it isn't really real-time data per se. Maybe that's where some of the confusions come in. But you say it's like, has my account reached X limit, bang, event gets fired off. It's not, so you're not constantly monitoring your account.
Yeah.
And this is where I think people, it's not really data management, it's event And then that goes async, isn't it, into
Yeah,
the
so
facilities, not real time.
yeah, so we can explore that a second. So with data management, you like real time is a low determined. So there's to break it down, there's like near real time, there's real time, there's kind of speed of light, real time, and with this you would call it probably near real time. So what this isn't, you wouldn't necessarily use a Kafka for ultra low latency trading apps as an example. So with ultra low latency trading apps, you want to operate in like hundredths of a millisecond. With Kafka, you can probably operate into like half a millisecond or 2 milliseconds. So if you're not that bothered between a millisecond or two, it's good. But so it's kind of, we always say real time, but sometimes we get picked up. Probably correct to say near real time. But, and then what we didn't talk about, we talked about a lot about Kafka. There's another open source technology called Flink. We didn't develop Flink actually, but Flink is a processing engine that sits on top of a stream of data and can be used to process and so if you're doing things like complex joins or analysis or rules based, do that in the stream, and that might add another 0.2 millisecond again. So that's, yeah, I don't know, Mark, does that answer?
Yeah, I've just seen it used in lots of machine learning environments, like feeding Cloudera and things like that.
Yeah.
So yeah, not so much the real time thing, but
yeah,
those big engines.
Yeah, I mean, for the most part, for human experience, in terms of something happening and then an update on an app, we tend to talk in our world, our real time world, that like Kafka's instantaneous, effectively, even though there's milliseconds in it. Any other questions? Are we done, Dalim? Oh, there's one at the back.
Yeah. So thank you. Talking about handling data in real time, we understand that this has to be around governance and security. So privacy at speed, how do you handle PIIs while processing this data in real time?
Yeah, so it turns out we can do that really well because of the governance. But now I say we, I mean, so I should step back slightly. So Confluent has, so we've talked about Kafka tonight and Flink a little bit because they're open source technologies, anyone can have them. So this isn't a sales pitch. Now, I'm going to add the sales pitch bit. It wasn't intentional, but Confluent has, because we created, the fact we created Kafka and we've acquired a team that created Flink, so they are now working for Confluent. And we've created a platform that has more than just the streaming and processing. It has like a governance layer and has other features and functions for management of large Kafka. And that governance layer can tag PII data. It has role-based access controls and has things that are quite hard to build actually if you're just using vanilla open source Kafka or Flink. So that's part of our value add.
And it has metadata as well.
That's why Confluent exists really. Otherwise, people would just use the open source stuff in enterprise. What we offer over and above that is the support, the management, but also the governance, and the additional kind of management features and functions.
Do you see like a prerequisite for using this tool is the data quality? Or would you need 100% quality in your data before sending it through? Or is there like a threshold?
Yeah, so we don't, for a while, we didn't talk about data. We talked about events, and these are events.
Yeah.
Events, a bit complicated actually. In the early days of Confluent, we talked about having an event streaming platform. COVID happened and people were calling us saying we need some sort of like streaming platform, like for video conferencing and I was like, that's not, because they were like, well, we're running an event and we need to stream that. A new sell event streaming platform. Okay, maybe we need to change the name to data streaming platform.
It's business.
So now we call it like it's a data streaming platform, but it used to be called an event streaming platform. But the events being events basically means there's no, I mean, if you set this up, there isn't a human inputting data. So you don't get the same data quality issues. You don't get, I mean, you can get like faults in network and so on, but Kafka's also, it turns out, like really redundant, brilliant to manage that. So 10 quality input in the stream, because you've shifted left to the source events. There's not someone putting in the date of birth in the wrong order or something. It's just doesn't happen in the same way as, you know, I don't know whether that answers the question, but
Yeah.
it's a slightly different model. I mean, the data quality tends to be a downstream kind of processing. And by the way, I know there's a question at the back, but there's with that operational and analytical estate, the analytical estate, which tends to these days be MongoDB, Databricks, Snowflake for the big data warehouse, data lake. They tend to implement something called a medallion architecture, which is they take data in the feeds of data and they have bronze. And bronze is like, it's okay to look at, but to do anything with, you're going to have to process it and clean it. That goes into silver. Silver is like, well, it's not bad, but it probably still, there may be duplication and other stuff, errors. And then it goes to gold, and gold's the kind of gold standard for use for reports. So they, like in the analytical world, you have data challenges. So that's how most people think of data. They think of databases for analytics. But we're largely in the operational world where the data is a different, there are other different challenges. But there's a question on the back.
Yeah, just to get my head around the events, because I think I've heard a few questions trying to nail that, and the left center approach is a good example, like looking at an Excel file to make it really simple, right? An Excel file online, you make a change to the cell, that an event level, or is it, 2 seconds later the file gets saved? Is that the event level? Because that's the difference between Linda's version of the data, and if I understand it as the initial version, that I took a stroke and that's an event, and I'm getting the information right from the source, and the information that happened. So I put a new letter. It's now L, the event, and the streaming straight away and telling me that it's E at that point in time. By the time you type up to add 2 more letters, 2 more events have happened, and I'm also streaming those 2 more events because I'm taking the log that says a stroke was, that's the event that happened, and that event, these are the attributes of that event. 1 extra letter was added to sentence. Is that the level of event streaming you're talking about?
We should stop with that.
Really good explanation for the difference between streaming and batch. Streaming is like every single letter is an event. And this is why when you use, Google Sheets or something, you're a lot, I don't know, whoever means like, Control S is batch. Like you've done a bunch of changes, but until you've actually sent them all together, you're at the mercy of Windows, I guess, where.
And they're both events. The batch event is a batch event, but the single event.
It's again, it's another saving is also an event, right? Every click would be more click stream.
Yeah. Okay, thanks. And thanks again for listening, and hopefully
Coming.